Hi and welcome to this presentation on the new Cerebral. My name is Christian Alfoni and I'm one of the people working on this project. I thought we would just dive right into it. So here I have prepared a tiny demo application where I can click load user. You see a small loading state there, and then it loads up a user and displays the name. Looking into the code here, we can see that we have a user component. And this is like how all frameworks work now. They have some sort of component concept. This is shown with React, but with Cerebral you can use many other frameworks and view solutions as well. So what we can see here is that we are defining all the logic within this one component. We have our initial state defined. We have a method that will change the state and run a side effect, which is grabbing the user. And then we render the view of the component or the UI of the component. In the main file, we just render out the user component. So what we're going to do in this demo is actually refactor this example into Cerebral code. But first we have to talk about why do we want to refactor this? Because this is a perfectly valid application. Many applications use only components and they contain the state of the application and they run the side effects within the components. Now, that will work just fine, and if that works for your application, please do so. But you might get into an issue as you scale up the application, because what we're doing is that the state structure and the side effects management is restricted by the UI structure, meaning that the way you structure your components for the UI affects how you can share state and run side effects. So in Cerebral, those concepts are two completely different things. Defining a state structure and running side effects has nothing to do with the structure of your UI. And of course, you can argue against that as well. And it's basically up to you how you feel about this. But I'm going to now show you how we can clean up this component and how we can make our code more scalable. So the first thing we are going to do is create a Cerebral controller. So let's create a controller file and we will import a controller from Cerebral. And we're going to export this controller. Like this. And as we saw inside the user, we had three state properties: is loading, user, and error. So what we're going to do is that we're going to define this on this controller instead. Is loading, false, user null, error null. Now, typically you would not define this directly on the controller. You would split up this logic into their own modules, but this is just for the example. Yes, so now we have defined the state, and as we can see here, we need to also run a side effect. But instead of using Axios, we are actually going to use an HTTP provider from Cerebral. So HTTP provider from Cerebral HTTP, and we are just going to add this HTTP provider to our controller. So the thing is that instead of you importing your side effects tools into the components themselves, we will use what we call providers in Cerebral. And providers allows you to define all the types of side effects you want to run. Typically, you define a lot of your own side effects, and then those are exposed into your business logic by Cerebral, and we will see how this works. So now we have the HTTP provider, and we are about ready to go. but we have one more thing we're going to add, and that is the DevTools of Cerebral. So if I import DevTools from Cerebral/DevTools, and we will just instantiate that with a host of localhost 8585, and we're going to save that. And what we're going to do now is that we're going to expose this controller to our components, and we do that inside our main file. So let's import controller from controller, and we also need to import what we call the container from Cerebral React. And this container is what exposes the controller to our components. Okay, so if we save this now, our application should work exactly the same way. But if we look into the debugger, we can see that we haven't triggered any signals yet. We're coming back to that. But if we look at the state tree, we can actually see the state of our application. And this is actually one huge object where we have all the state of the application, and you can explore it as much as you want. But it's not like you define everything in one big file. You split it up into modules, but it comes together at the end. So now we have a Cerebral setup. So let's start refactoring. So first of all, we do not need to define the state anymore. So let's remove this. And now we have to handle this load user. So instead, like in Cerebral, we don't create like methods. We create what we call signals. So let's replace this method here with a signal inside the controller instead. So signals, and typically you name these signals in past tense. So load user clicked, for example. This is just an opinion. You don't have to do this, but it's a typical thing to do. And it's part of thinking of the UI as a very stupid thing. The UI just says, okay, something was clicked on me, and then it's up to Cerebral to decide what actually happens. So the UI doesn't really have any notion of go and load the user. It just says someone clicked a button. That is about loading a user. Yes, so the first thing we want to do here, we want to change the state. But instead of using imperative code like this, we are going to use declarative code. And Cerebral has a set of what we call operators that allows us to do that. So we import a set operator, and we also want to import what we call a tag. And what this allows us to do is set state is loading to true. So we define a signal using an array, and then we use a declarative code, like functional code, to define that we want to change the isLoading state to true. And then we want to go and grab this thing here. And the way we can do this is actually use an operator from the HTTP provider. So we say Cerebral HTTP operators, and we say HTTP get, and then the URL. And then we can say that the result we get from this, we want to set to the user. So we want to set from the result, and we use a new tag called props. And then we finish this off by saying isLoading is false. Like that. So what we're doing here now is that instead of having one method where we tightly integrate imperative code, we are reusing, everything here is reusable parts. And you can compose them together in any order, and you can use it in any other signal as well. And this is one of the benefits of declarative code. Another benefit is that you don't have to, there's nothing about how we change state or how we go and get a user. It's only about what we want. So instead of figuring out what is happening here by reading how it happens, you only have to read what happens. So it's a less of a mind load to understand declarative code. Okay, so now that we have that in place, we can remove load user. And then we only have render here. So why have a class when you only have a render method? Well, we don't need that. So what we can do is rather create a function called user, and then we return. And where we and the question then is, where will we get our state? And what we can do with Cerebral is actually connect the state to the component. So what I'm going to do now, I'm going to import connect from Cerebral React. And what I'm going to do is, rather, instead of exporting here, we're going to export default connect. And we're going to reuse our tags. Tags are just a way to reference something in Cerebral. So what we want here is loading, which is available there. We want the user, and we want possibly an array here. And then we rather put our component inside here. And now we have isLoading available, we have user and error, which means we can remove all this logic here. Like this. And here. Let's see. And maybe we can just also import our signal here, which is also a tag, and called load user clicked. And we got that on load user clicked, like this. Okay, load user click. Okay, so let's see if this works now. I have my connected component where we grab some state and a signal. We export it as a stateless function. And that should be it, really. Let's see. So we have load user here. I can click it, loading user, Leanne Graham. Cool. There was a mistake there, but I think that was because I had a small typo. The isLoading was supposed to be false. So let's try again. Loading the user, and we got the username, just like before. So what's interesting now is that when I go into the state tree now, we can see that I actually loaded the user, and we have all the information about the user, which we can explore. But if we move to signals, we can also see how this user was fetched. We can see that we're running a sequence of what we call actions, which are basically just these operators or your custom functions, where we first change the state, we go and do a HTTP request, and we can see the output. We got the headers, we got the result, and we got the status, and then how we set that state after that. So since we write this declarative code, we have the possibility to inform the Cerebral debugger about everything that is happening, which is a great benefit. Another great benefit here is that any connected component you define, they will not render by default. But since we define what this component is interested in, it will tell the component specifically to render when there is a change to any of these dependencies. And that just automatically optimizes your UI, which is really great. But now we didn't really handle the error here, did we? So what we're going to take a look at now is like this is an optimistic signal. It just runs through, and if there's an error, it will just throw. You are actually able to catch these errors and run other business logic, but we are just going to show how you can handle this within the signal itself. So instead of just continuing with setting the result here, we are going to add a success and we are going to add an error. So when there's a success, we will set the user with the result, or if there's an error, we will set the error with the result instead. So using an object inside the signal allows us to define what we call paths. And you can define this yourself. And these paths are not about success and error. That's just a coincidence. It can be anything. It's about execution control and diverging execution. So let's see what happens now. If we click the button again, it's still loading the user. And as we can see here inside the debugger, we can see that it didn't run down the error, it ran down the success. So if we go back here now and we change to ABC, for example, which is an invalid URL, we got loading user, and we got an error, but something wrong happened here. So let's see what happened. You're passing a non-serializable value into the state tree on path error. Okay, so what actually happened here was that I'm using the result. As you can see here, I'm using result, but actually it's an error. That is why it throws. So if we change this to error now, we load the user again, and then we have, and then it works. But as we can see, we did not have any message there. And that's basically because there wasn't any message. But we could define our own, for example. We could say, could not load user, like this. And if we load again, it should have set the state to user. What happened here? Oh, we had an issue with state. Let's try again. Loading user, could not load user. So now we've been looking into how we actually write Cerebral code. To summarize, we expose a controller to our components. The controller handles all the state and side effects, and we allow the UI, the components, to handle UI. The controller has a powerful development tool, the Cerebral Debugger, which gives us a lot of insight into how we run signals, how we structure our state, and so on. And it has providers, and providers are side effects. So we define side effects on the controller, and those side effects are then exposed to all the business logic you define in Cerebral. Then we have our state, and we have our signals, which are declarative, meaning that we are reusing small pieces of logic and putting it together, allowing us to it gives us more flexibility to scale our application. And then when we want to expose state or allow a component to trigger a signal, we just use the connect, and that will automatically optimize the component, and it allows us to normally just write stateless components. They are only about UI, and they rather depend on state and signals. I hope this gave you some insight into how Cerebral works. But to summarize the concepts of Cerebral, first of all, you free your state and side effects from UI structure. As we mentioned in the beginning of the demo, if you define your state and your side effects within a component, you restrict its usage. You have to restructure the UI, or you have to move side effects or state around to other parent components to allow children components to access them. And it's a very tedious task to do when your application scales and you get into this issue. Second, we force a declarative abstraction of business logic. As you saw when we defined the logic within Cerebral, we didn't manually describe how to do this. We just did it using existing Lego blocks. And you will, of course, create your own Lego blocks, but you are encouraged to do it in such a way that makes it very reusable. And these pieces of logic can be composed together in any shape or form, which makes it very easy to scale up your application, and you will never refactor your UI because you change your state, for example. And of course, Cerebral has a pretty amazing debugger that understands your application. It understands the flow of everything that's happening, meaning that when you get a new team member, for example, you can just sit down with them and open up the debugger and let them click around in the UI, and they will understand everything that's happening. And this is also a very valuable tool as complexity grows. Like the example in the demo was very simple, but these signals can grow very large depending on your stack and how complex your application is. But it will always show you step by step what is happening. And there is also more to this debugger, so please dive into more documentation and read more about Cerebral. Thanks a bunch for taking a look at this, and I hope you enjoyed it.